Welcome to Mr. Marquise Tutors Me. I am Mr. Marquise, and this is my multiplication and division tutorial. I'd like to thank you guys for coming out. I definitely appreciate you for coming to this Mr. Marquise Tutors Me YouTube page, which is at Mr. Marquise TM on Facebook. I definitely appreciate you for swinging by. This is my multiplication and division tutorial. Now you're going to learn about ratios, percentages, different ways of measurement. You can definitely find Mr. Marquise at Mr. Marquise Tutors Me at Gmail or Mr. Marquise Tutors Me at protonmail.com. And that is for any questions you may have after this multiplication and division. I don't have any particular questions or anything in particular that was asked of me for this multiplication and division tutorial, but I was asked for assistance with helping some 9, 10, 11-year-old kids learn how to multiply and divide a little faster and understand it a little more. So the first thing I did was I went and got me a booklet and some paper, and I sat down and just started writing. So that'll be the first thing that I need you to do. I need you to go and grab you some paper, pencil, and just get you some personal space to where you can just give me your undivided attention, because I will need your focus and attention. This multiplication and division is something that just carried over from your beginning when you first started arithmetic. The first thing you did was learn how to count and identify the numbers. And with that came addition and subtraction. So now multiplication and division are just forms of adding and subtracting. You just have to add more and subtract more when you're multiplying and dividing. So I'll definitely need your undivided attention, because I went back and watched a few of my other tutorials and I noticed that I talked a little too much. So in this one, I'm just going to get right to it and say, hey, this is what it is. This is what it is. If you need to stop it, write whatever you need to write and then come back to it. We'll definitely be here. And that is you giving me the best you. I need you to be the best you during this tutorial and being the best student you can be from here on out, because you're going to see these numbers everywhere you go from here on, because I'm going to relate it all to your life. After this, man, you are going to love math. And I wouldn't say that those are rules or the regulations of being here on my page, but this is what I need from you. Number one, paper, pencil, personal space, your undivided attention. I need you to be the best you. And by the end of this, you will love math. I promise. So for practice, go ahead and you have your pencil and your paper. We're going to take that first piece of paper and we're going to start from the beginning. I had to start all the way over. Just to bring you this tutorial, I had to go back and write down numbers to 100. So I started. Now that 0, can you write that to the left of the red line? If you have lines on your paper, write the 0 to the left of the red line, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Give yourself enough space. If you need for it to be perfect spacing in between, go ahead and put 2 fingers in between every number you write, or 1 finger. Yep. I put 1 finger, and 1 finger is enough in between each one of the numbers, because I need you to write your 11 through 20 like this, 21 through 30 like this. I need those ones to line up. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want you to notice that a 0 starts your counting or your number system. 0 is the first number, but it is nothing. That means you have nothing. And in order to get to 1, you have to add 1 to nothing. Now, by the time you got to 9, you have to go back to the 0, but that 0 has a 1 in front of it. So I need you to write 0 to 100, just the way you see it. Now, just as I was just saying, to get from 0 to this 10, you had to basically add 1 to each number. 0 plus 1 was 1. Now you're starting at the 1. 1 plus 1 is 2. And now your point of origin is the 2. You have to move to the 2. Plus 1 was 3 until you got all the way to the 10. And then the numbers started over. 1, 1, 1, 2. All the way until you got to 1, 9. And then it was a 20. But what you did was add 10. 10 plus 10 is 20. So 2 10s is 20, right? 20 plus 10 is 30. So 3 10s would be 30. Now, I want you to see that you've actually been adding and multiplying the entire time of you just writing numbers down. And you got all the way to 100. And then that 100 started back over to 101. You got up to 109 and it said 110, which is 110. And then it got all the way to 190 and 199. And then after that 199, it has to go up to 200 and you start over 201 until you get to 300. 400s is 400, 500. Now you can also look at it as like you went from 90 or 9 10s to 10 10s, and 10 10s was 100. 20 10s is 200. 300, 400, 500, 600, 700, 800, 900. Now I need you to write the next line as just like this. Like we had the 100 at the end, go ahead and write that 100 where the 0 is. That way you can write 100 over to the left, and then you have 200, 300, 400. So the 1,000 will be over here to the right. 1,000, right? 1,000 ended up being 1,000. So we started with 0. We went to 1. 10 is a 10. 100 is a 100. 1,000 is 1000. So now 10 times 100 is a 1 and 3 zeros, right? 2,000, 3,000 to 10,000. Okay. 1,000, we jump down to 2,000. But if you look up on the 200, that is 200 times 10, or 200 10 times would be 2,000. So yes, we went from 1,000 to 2,000 to 10,000. 10,000 times 2 ends up being 20,000. So if I have two 10,000s, I have 20,000. 20,000, we can get there from having 200 hundreds. 200 times 100 is 20,000. Because 100,000 times 10 is a million. Just like 1,000 thousands is a million. 100,000 times 10 is 1 million. Times 10 is 10 million. Times 10 is 100 million. Times 10 is 1 billion. Times 10 is 10 billion. And then you have 100 billion. And after that, it is 1 trillion. Yes. 1,000 billions is just like saying 1 trillion. A million millions is just like saying 1 trillion. I'll break that down for you, but this is just your practice. I want you to write these down. Don't worry about what I'm saying. What I'm saying may confuse you, but if you can actually see it and say it, you'll remember it. As you're writing it and saying it and seeing it, you're actually writing it in your head. I just want to get you to the point where you say, okay, 1 million can be, I can get 1 million from 1,000 times 1,000. Just like I can get a trillion saying a million times a million, or a million millions is 1 trillion. A million times a million is 1 trillion. So I can say a million millions. Just like I can say 1,000 thousands is 1 million. It's the same thing. 1,000 times 1,000. Now let's say I move a zero from the right side to the left side, making it 10,000 times 100. That's still a million. 100,000 times 10 is still a million. 1 million times 1 is 1 million. Or 1 times a million. That could be a million ones. A million $1 bills is still $1 million. Now we have placements. This first zero is the ones place. Only thing can fit in here is 0 to 9. Same thing in the tens place. Once you get up to the 9 in the ones place, the 1 goes to the tens place and the ones place starts over. So it's like 1, 0, making it 10, right? That's the only way you can have a number in the tens place is if you have 1 10 at least. And 10 starts it, 99 ends the tens place. A 9 ends the tens place, making it 100. Now you go back to the hundreds place, right? You have to have at least 100 to be in the hundreds place. That ends with the 9. And it starts over. 999 gets us to 1,000. 10,000. 100,000. The places start with 0, end at 9. When you move to the tens place, the 0 starts over. Goes from 10 to 19. And then that 1 turns into a 2, right? You have 2 tens. The 1 starts over. Goes up to 9, takes it to a 30, goes up to 9, and then the 10 turns to 40, turns to 90, 99, and then the hundreds, 999 before you can get it up to another 1,000, 2,000. 999 goes up to 3,000, but 9999 goes up to 10,000. 99,999 plus 1 goes up to the 100,000s. 100,000. So 100,000. You start the ones over, go 9. Then the 10 goes to 1. The 0 starts over. 1,019,000. Once it gets up to the 9, you add 1. It's 1,020,000. 1,099,000 goes to 1,100,000. You can see the places the ticks are going. Now these ones are going faster than the tens, which is going faster than the hundreds, which is going faster than the thousands. The ones place is a single digit number because it's one number. From 0 to 9 is just one number written down. That's why it is single digits. A single digit, I should say. Now, the tens place makes it 2 digits, but we say double digits. Just have you ever heard the announcers at a basketball game say, Steph Curry has his first triple-double? That means he had double figures in 3 statistical categories. Those stats could be points. You could have at least 10 points, 10 rebounds, 10 assists. He could have 10 turnovers, 10 steals. Either way, if he has 3 of those double-digit stats, it's a triple-double. That is the double digits. And then triple digits is 100 to 999 because there are 3 digits, right? Triple digits, quadruple digits. Quadruple, we just go ahead and say 4 figures. It's the same thing. Triple digits is 3 digits. 4 figures is 4 digits. It's the same thing. 4 numbers. Until we get to 6 figures, which is 100,000. Now, if you see a $1 million, you see 7 figures. It usually has the 2 commas there. So after 3 numbers, there's a comma, and those 3 start over again, right? It's like a ones place, tens place, hundreds place, comma. Ones place, tens place, hundreds place, comma. 1 million, 10 million, 100 million, comma. 1 billion, 10 billion, 100 billion, comma. You'll keep seeing those commas. Now, You add a 0 to anything, to any number, and it's going to be that number. 3 plus 0 is still 3. You add a 1 to that number, you get the number after that number. Like 3 plus 1 is the number after 3. 4, right? So you can add 0, you can add 1. Just like 0 plus 1 took us to the number 1, it's different with multiplication. With multiplication, your 0 times 1 would be 0, because anything times 0 is 0. Now imagine having to write 0 one time, or having to add 0 one time. You would just write a 0 because you're writing it one time, right? Now flip the numbers. 1 times 0, you'll write 1 0 times, or you'll add 1 0 times. If you're not adding 1 at all, then you're not writing anything, but the teacher needs a number. So 1 times 0, you're going to have to write a 0 because it's nothing. 0 times any number is 0. Any number, positive or negative. 0 times any number would bring you back to 0, because you could write 0 however many times that is. If it says 0 times 9, you write 0 9 times, add all of those zeros up, and it is 0. You know what I'm saying? I'm just trying to explain why these answers are what they are. Now, you take that same number 9 and multiply it by 1, and you'll say, okay, add 9 one time. I'm going to just put a 9 down. 9 one time. That's 9 one time. If I just put the 9 down. Now the 1 times 9, I write 1 9 times. 1 1 1 1 1 1 1 1 9 times, and add them all up. It'll give me 9. Any number times a negative number would make your answer negative. No matter what. No matter how big or small. Any number that is positive, no sign in front of it, times a negative number would make the entire answer negative. You cannot have a negative 0. Okay, so 1 times 1 is still 1. You're going to add a 1 one time. 10 times 1 makes it the number, right? You'll write a 10 one time, or you'll write a 1 10 times. It's the same answer. You add a 1 10 times, you'll get to 10. I'm trying to show you why these answers are correct, not just tell you that 10 times 1 is 10. No, I'm going to tell you that you can write, or your mom can give you 10 $1 bills, or you can just have one $10 bill. It's the same 10. It's the same 10. So 10 times 10, I can say that I have 10 tens, or I can say that I have 100, because 10 plus 10 plus 10. So we take 10 of those 10s, we write them down 10 times, add them all up, and it'll bring you back to 100. You can have 100 ones. You can have one $100 bill. Now, 1,000 is just like 1,000. 100 tens is just like 1,000, because I'll take 100 and add it 10 times, or I take the 10 and add it 100 times. When I add all of those up, it'll get me to 1,000. Now 100 hundreds, which is 100 times 100, right? 100 times 100 will get you 10,000, right? Just like if I moved one of the zeros over to the other side, it would say 10,000s, or 10 times 1,000, or it'll say 1,000 tens. That's still 10,000. So now I have 1,000 times 100. So that's 1,000 hundreds, and it's 100 thousands. It's $100,000, or 6 figures. Now, 1,000 times 1,000. All you really want to do is say, okay, 1 times 1 is 1. And then you just write the 6 zeros behind it. However many zeros you see in the problem, it will have that many zeros in the answer. If you have a 30 times 2, you will at least have 1 0 in that answer. If you have a 30 times, let's say, 30 times 30, you're gonna take the 3 times the 3, 9, and you'll know that you have to put both of those zeros, 900. 30 times 30 is 900. Just like 10 times 10 was 100. Now, we have just passed the practice stage. So yes, the practice stage may take you about 10 to 20 minutes, but we had to get that practice down. I had to get your mind ready for these big numbers that you're going to see. And basically, I go back, turn the page, and I'm going to start with 1 times 1 equals 1. And then 1 times 2 equals 1 plus 1, which I just wrote 1 2 times, or I wrote 2 1 time. So I have 1 times 2 equals 1 plus 1 equals 2. I have 1 times 3 equals 1 plus 1 plus 1 equals 3. And you'll do that until you get to, I went to 11, but most of your books, your math books and stuff, they go to 12. So multiply 1 times 12, go all the way to 12. And even when it's time to go all the way to 12 times 12, go ahead and do that. Now, just like I said, 1 times 2 is 1 plus 1, or it is 2. And that is the same as saying 2 times 1. It's going to be the same answer. 1 times 2 is 2 times 1. 1 times 3 is just like saying 3 times 1. Even if one of those numbers is negative, it does not matter. Your answer will either be a 3. If both of the numbers are positive, the answer will be positive. 2 negatives multiplied together comes back to a positive number. Only one negative in the problem changes the answer to a negative. Like there has to be only one negative. Like if the 1 is a negative. If it's 4 times -1, the answer is -4. If it's -4 times +1, which will just be a 1, you don't have to write a +1. If the problem says -4 times 1, the answer is -4. One negative makes the entire problem negative. So write it 1 times 1 to 12, and then we come to 2 times 1 equals a 2, or it equals that 1 plus 1, right? We can write 1 2, or we can write 2 1s. 2 times 2 is 4. 2 times added is still 2 plus 2. So 2 times 2 is 2 plus 2. Same thing. 4 is 4. 2 times 3, write that all the way. Keep going exactly how I have it. You write 2 4 times, 2 5 times, 2 6 times, and you'll see that the answers are doubling. 2, 4, 6, 8, 10, 12, 14, 16, 18. 2 times 10 is 20. 2 times 12 is 24. And the same way with your ones, you could write a 2 times 1 is a 1 times 2. You can do the same thing with these 2s. 2 times 3 is just like saying 3 2s. Instead of me adding 3 2s, I could add 2 3s. 2 times 3 is 3 times 2. So 3 plus 3 is the same 6. 4 plus 4 is the same 8 that 2 plus 2 plus 2 plus 2 is. You see it? I want you to write all of these down because you're going to need them going into the next thing. This was the first bit of adding and subtracting, multiplying and dividing that you should have received. You should have been writing these down and not just saying that 3 times 1 is 3 times 1 because that's what they said. No, I need you to see that a 3 times 1 is a 1 3 times or a 3 1 time. This is how you actually understand mathematics, arithmetic. So you'll go all the way to 3 times 9, 3 times 12. I actually want you to go all the way to 12 times 12. So after this 3 times 1 goes all the way to 3 times 12, go to 4 times 1. Down to 4 times 12. Same thing. Same thing with this 3 times 9. You can write 9 3 times, or you can write 3 9 times. Most of the time, I try to use the bigger number, but you don't necessarily have to. Now, I did the 3s, I did the 9s, but when you get up to 9 times 9, it's like, yeah, you know that it's 81 because you've been told so many times or you've seen it so many times. But if you add all your 9s up, you'll see that it's 81. And then when it's time to get to 9 times 11, you'll say, okay, what's 9 times 10 first? So you have an 81, you add 9, and that'll give you 10, which is 90. 10 nines. 10 nines is 90. So 11 nines, you just add another 9. 90 plus 9. Now, you can get that 99, or you can do multiplication. Actually, multiply it. Set it up like this. 9 times 11 or 11 times 9. And you want to multiply straight down the 9 times the 1 first, and then the 9 times the tens place, right? 9 times 1 is 9. 9 times 10 is 90. You add those up, that is 99. And you just write them right there together. The first 9 and then 99. Even if it were upside down, you'll take that 1 times the 9 and then the 10 times the 9. Same thing. You can only see a 1 and a 1, but you know that this is 11, right? So 11 times 9 is 99. So let's go back to our 0 through 100. Don't write it again. Just turn the page back to your 0 through 100, and you can actually see every number. Just go in and pick a number. If you say 9 times 9, you can go and say, okay, that's 9 plus 9. You can put your finger on the 9. And then plus 9, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll see it jump to the 18, which is basically a 10 minus 1. So if I jump down 10 minus 1, my next one is 27, right? So that's 3 9s. 10 minus 1 is 36. Yeah, so after 36, the next number is 45. And you say, okay, 1, 2, 3, 4. That's 5 9s. 6 9s is 54. You see it going down to the 81. You see it jumping to the 90. 99. I mean, you see it jumping to 99. 12 times 9, if you look at it, it's 108 because the 2 times 9 is 18. You carry the 1 and it'll give you a 10. 108 if you're looking at it. What I really want for you to do is to take any 2-digit number and multiply it by any 1-digit number. I have, and write this down, 47 times 6, 72 times 9, 88 times 4. Now, when I'm multiplying, I take this single digit, the one that's by itself, and I multiply it by the ones place, put the answer down, and then I multiply it by the tens place and put the answer under that 10. So 7 times 6 is 42. I write the 2, carry the 40 because it's going over to the tens place. You have 4 tens that need to go over to the tens place. Now we'll multiply this 6 times 4 and then add that 4. So we have 6 times 4, which is 24, plus the 4 is 28. So I have a 282 as the first answer. Same thing with the next one. I'm going to take this 9 times 2 and then 9 times 7. So the 9 times 2 was only 18. I wrote the 8, carried the 1, which is going to the tens place. 9 times 7 is 63, plus the 1 is a 64. The next one says 8 times 4 is 32. I put the 2 down. I carry the 3. 8 times 4 is 32 again, but I have to add 3 more tens to it, making it 352. 352. And that's just me making sure I'm adding and carrying and then adding again. Now, scratch those out. Those that you carried over, scratch those out, because now we have a tens place that is also being multiplied by that. Now you'll do the same thing. Now you'll take the tens place, multiply it by the ones place and the tens place. So the 1 gets multiplied by the 7 in the first question. Going back to the first problem, 1 times 7 and then 1 times 4 is essentially 10 times 7. That's 10 times 40. You know what I'm saying? So this 1 times the 7, since we're multiplying in the tens place, the answer goes in the tens place. 47. You see it? 47 times that 1, or 47 times 10 is 470, right? 47 times 1 is 47. But since we're in the tens place, we have to put 47 tens, which is 470. Same thing with the next one. We take the 2 times the 2, and that's a 4. You're not carrying anything. 2 times the 7 is a 14. So I should have 1440. Now, what we really want to do is go 8, add it, 8, 8, 2, 0, 20. 14 plus 6 is 20. 4 plus 4 is the 8. And 8 plus 0 is the 8. Yes, and you definitely want to add. You're going to take the ones place, multiply the 47 times the 6 and get 282. And then the 47 times 10 is 470. But you want to add both of those. Same thing with the other one. 88 times 4 was 352. Now 88 times 90 is 9 times 8, 72. 9 times 8, 72, plus the 7 gives us 7920. Add all of that up, you get 8272. Now, take your time. I'll give you a little bit of time to do it over. You can go back, rewind. Okay, rewind that. Let me see, how did I get this answer? Now, there is more than one way to do this. As I was saying, you can break it down to 47 times 10 plus 47 times 6, and you'll get 470 plus 282 anyway. It's going to come back to the same answer. It's more than one way to do multiplication. So yes, the teacher may teach you one way. Mr. Marquise may teach you a different way, but at the end of the day, the answer has to be right. Yes, show your work, but it's more than one way to get there. So utilize as many as you may need. Like, you may need to go out to the side of this 7 times 6 and write 7 plus 7 plus 7 plus 7 plus 7 plus 7. That's 7 6 times. And then you add 7 and 7 is 14. Those two are 14. This 2 is 14 and this 2 is 14. So 7 6s, or 6 7s turned into 3 14s, right? So we take a 14 plus 14, 28 plus 14. Will get us to this 42. You can come out to the side and actually add them, multiply them. But if that's how you have to get to your 42, then by all means do it. If you have to use your fingers for anything, if one finger equals 10 million, you need all 10 fingers. Yes, use your fingers to get to your 100 million. Now, I have a word problem. In Tom Brady's pro football career, he has played in 318 games, averaging 264 passing yards per game. How many total yards has Tom Brady thrown for? Okay, so I have 318 and 264 passing yards in each one of those games. So it's going to be 318 times 264. Now, if I don't want to, try to figure out how to multiply all these big numbers, I can break it down and say, okay, 318 times 264. I can break it down and say 318 times 200 is this. 318 times 60 is this. 318 times 4. So I can break it down like that, but you got to remember to add them up at the end. So I took my 318 times 4 and I got 1272. I took my 318 times 60 and got 19,080. And then 318 times the 200 was 63,600. And I have to add all of those up. It would be the same if you were to say 318 times the 4 is the first line. 318 times the 60 is the second line. 318 times 200 gives me that 63,600 because it is in the hundreds place. It's the same thing. Now we add and straight down and we get 83,952 total passing yards. Now, the teacher can say round to the nearest 1,000, and which 1,000 is the closest? Is it 83,000 or is it 84,000? Are we going to round down to 83 or round up to 84? And that all depends on what's after the 1,000. If it's anything higher than 500, 500 is half a 1,000, right? So anything higher than 500 will get it closer to 84,000. So if the teacher said, hey, round to the nearest 1,000, it would be 84,000. If it said round to the nearest 100, we'd go to that hundreds place and it says 9. And then we'll look at the number after the 9. If it's 5 or more, we round up, which would get us to 84,000 anyway. You know what I mean? Because you round the 900 up, it's going to go to 1,000, an extra 1,000. So 84,000 plus or minus yards is what Tom Brady has thrown for in his career. If you got the right answer, good job. That means you're learning this math as fast as I need you to learn it. If not, you can always go back and learn it. However your teacher taught you to do your multiplication, see if you get the same answer doing it their way. And I'll have a couple of more word problems, but for right now, I'm going to let you know that we're just going to move right into how multiplication introduces dimensions. Multiplication introduces dimensions. Let's say in dimension 1, we had nothing at first. We had nothing, but you put a dot there. And say, let's say that dot is 0, right? 0. So this is the starting point, the reference point. This is ground 0. So we take that, and in order for me to actually relate it to life, I say that I am the dot, or you are the dot. And where you are standing is ground 0. That is a straight line. So imagine your eyes being the straight line. Whatever you're looking at, whichever way that arrow is pointing is wherever your eyes are looking. And your eyes are your point of view, and it's always a straight line, right? So this is your line of sight. Now, close your eyes, and you're back to nothing. You can't see anything, right? You open your eyes, and it's that straight line. That straight line starts to count positively as you start to see objects in front of you. If there is something in front of you that you are able to see, that starts number 1, and you can move to that 1, and now the 1 is your point of reference, right? Like if 1 is added, you just take 1 step forward. So in this case, we'll say that the 1 is a step. For every step you take, we'll add a 1. Now, the only way you can see the negative numbers, you can't see them right now. Okay, can you see behind you? The only way to see behind you is to turn around, right? You turn around exactly in that straight line, turn around and look directly behind you. And that gives you the negative aspect of this line. The line is there. Only the line is there right now. But you turn back around and you add 1, and you get to go and take that step to number 1. Now, if we were to subtract any numbers, we'll turn around and walk back the other way. Or you can actually walk backwards, moonwalk if you have to. But that line extends past this 1 that you stepped up to. But you know that there is that 1 step right there. You can put something there. Say a tree. Say a tree is 1 step ahead of you. So you walk up to that tree, and now that is the point of reference. Now this line can go to the negative side, but we have a 1 step in front of us is a tree. Behind us, 1 step. Let's say it's the sidewalk. You have a sidewalk behind you, 1 step, and in front of you, you have a tree. So now, let's say that straight line is 180 degrees on both sides, meaning it took you had to actually turn around 180 degrees to see the negative. You had to turn around another 180 degrees to see the other side. So let's say that this line is there, but you're not looking at it front to back anymore. You actually turn to the side. That way you don't have to turn your neck all the way around trying to see behind you. So now we have the line, and if you put your arms up to the side, looking like Jesus on the cross, you'll be able to look from the negative side. Let's make that the left side. You'll be able to look from the negative side to the positive side. And from that 0, the space that is in between, the space in between from where your left arm is to your right arm is 180 degrees. So you can see the space in between your arms. That's 180 degrees. You don't have a point up there. So you don't have a spot as far as a number is concerned. You just know that the space is there because you can see it. If you're looking from your left hand, trying to get to that straight line, you can see the entire space in between that line. And as you make it to that right hand, you realize that is 180 degrees. And the other side, you'll start at 0 to get all the way back to this other side. If you turn around to get back to this other side, now this side becomes the left, right? And you look to the right and you can see the entire space. You can see the entire space in between there, right? So that's 180 degrees. Put your hands down and you can turn around and see the entire 360 degrees of space. that is on either side of this line that you have created. You actually created that line. You either drew it on the paper or you could make it with your hands, but you know that line is there. Now, there is 180 degrees of space on both sides of the line. Now, what if I divided that 180 degrees into two? 180 divided by 2 would be 90. The same way dividing this 360 into 4s is the same 90. So now it's divided into 4 and you're at a 90-degree angle. Each pie piece, let's say it's a pie now. Each pie piece is worth 90 degrees. And this is where your building blocks come from, because that space in between the lines, which looks like an arm and a leg. You have an arm going up and a leg laying down on the ground. Now, that 90 degrees doesn't have to be on the baseline like that or straight up like the wall, but this is exactly how they measure your wall, your ceiling, your doors. If you look at your doors, you can see 90-degree angles in the doors. If you didn't have 90-degree angles in your home wouldn't stand up straight.